Hi, Mr. Sapone here, and today we're going to look at some percent flotation problems. And there's an expression you probably heard of called just the tip of the iceberg. And what does that actually mean? Well, 90% of an iceberg is usually below water. And the same thing is true if you have ice cubes in a cup of water. About 90% of an ice cube is below water, and only about 10% of it is above water. So if you were in the ocean and you saw a giant iceberg like this in the picture, that's only about 10% of the actual ice. The other 90% will be submerged beneath the water. And this here is an artistic rendition of an iceberg. You see about 10% above and 90% below. And that kind of gives you an idea why a big ship like, say, the Titanic might have accidentally hit an iceberg. Most of it is underwater. It's going to be hard to see exactly where it starts. But you should know that if you see ice out of the water, there is a lot more underneath because 90% of the ice will be submerged or beneath the surface of the water. That's what submerged means. Think of submarine. Submarine, it goes down below the surface of the water. There is a formula we use to calculate how much of an object will be above or below water. That formula is right up here. You take the density of the object and you divide it by the density of water or whatever fluid or liquid you are putting it in, and you multiply it by 100. And we'll do a problem with this in a second. First, if we had a cup of water here, water has a density of 1 gram per centimeter cubed. So the zinc is much denser than water, 7.13 grams per centimeter cubed. The zinc should, in fact, sink. The zinc is much denser than water, and zinc will, in fact, sink. The ice floats because why? Well, the ice is less dense than the water. It's less than 1. Its density is less than 1, so the ice is going to float. How much of the ice will be underneath the water? That's what we want to calculate. And if we were to take the density of the object, which is 0.92 grams per centimeter cubed, and divide it by the density of water, which is 1 gram per centimeter cubed, conveniently any number divided by 1 is itself. So this is going to equal 0.92. We don't even need this. The only thing, the units will cancel. So all you're really doing is taking the density of the object and multiplying it times 100. 0.92 times 100 equals 92% submerged. So that means 92% of an ice cube in fresh water should be underwater, roughly 92%. So if 92% is underneath the water, the other 8% must be above the water. And I have a cleaner version of that right there. Remember that in terms of percents, you can only have 100% of something. That's everything, 100%. If 92% is under the water, there's only 8% left. So about 8% of an ice cube is visible in a glass of water. About 92% underneath. It's different for salt and fresh water because salt water is a little bit more dense than fresh water. So the ice will float a little bit higher on salt water. You have a little bit more above water than fresh water. So we have two problems here. We're just going to do both of these problems just to make sure we understand this. And again, we are simply taking the density of object, dividing it by the density of water. The density of water is 1, so for practical purposes, if we're dealing with water, and if we're not dealing with salt water or some other weird substance, we can cross this off. We can just take the density of the object, multiply it by 100. So a branch snaps and falls into a river. That branch has a density of 0.7 grams per centimeter cubed. And will it sink or float? Well, that will float. It is less dense than water. Its density is less than 1, so it will most definitely float. How much of it will be visible? So we know that if we take the density of an object and multiply it by 100, that tells us the percent submerged. 0.7 times 100 equals 70%. That is not what is visible. That is what is underneath water. That is what is submerged. If 70% is below the water, then roughly 30% or whatever's left over should be above the water, because 70 and 30 add up to 100. So roughly 30% above, 70% below. Remember that this formula tells you what is underneath the water, not what is visible. You gotta subtract and get a difference if you want to do that. The second one, a little bit more challenging. A basketball has a mass of 624 grams. Mass equals 624 grams. And a volume of 7,512 centimeters. 7,512 centimeters cubed, I should say. What percentage of a basketball will be visible above water? Ooh, tough question, because we know that the formula is if you cross off water, density of the object times 100. They do not give us a density, but they give us a mass and a volume. And density equals mass divided by volume. So you could actually take the mass and divide it by the volume. So 624, which is the mass, divided by 7512. And that's going to equal a density of 0.08, a very small number, grams per centimeter cubed. So now we know the overall density of a basketball. And in order to figure out what percent will not be visible, but what percent will be submerged, we take the density of the object and we multiply by 100. And 0.08 times 100 is going to equal 8%. So 8% of a basketball will be submerged. If 8% is underneath water, then you must have 92% above water. You kind of got to take 100 minus 8 equals 92. You get a difference from 100 if you're a little confused on how that works. But if 8's under, 92's above, these got to equal 100. So if we had a basketball, just a very small portion of it would be under the water. And it's a terrible basketball, but the majority of it would be above water. Hopefully you know how to calculate percent flotation and figure out how much will be visible and how much will be submerged on objects. This is Mr. Spohn.